Welcome back, everyone. We are going to finish up section 3.6, and we're going to talk about derivatives of logarithmic functions. In the last video, I did inverse trig functions. Okay, we're going to start with y equals the ln of x, then y prime is 1 over x. Now, of course, we need to always keep in mind chain rule is now always going to be a part of this. So if it's not just x, it's x squared or something, that we need to do a 2x, right, as we do that. And this would be an x squared. All right, I want to show that, and by the way, this is base e. Hopefully we remember the natural log. We never write this in, but I'm going to put it in anyway. It's base e. So when we have a derivative of a logarithm that's not base e, what we're going to do is, let me derive this. We're going to go y equals log base a of x. And if you recall, the change of base looks like this. I'm going to change it to base e, ln of x over ln of a. So this derivative becomes d over dx of ln of x over ln of a. Now, the ln of a is not affected by the derivative. It's a constant relative to the variable x. However, the ln of x becomes 1 over x. So this becomes 1 over x times the ln of a. And so you can see where that comes from. So once again, if we're given y equals log base a of x, then the derivative is 1 over x times ln of a. And we'll run into that today. All right, we just have a few examples to go through. Let's start with example 4, part 1, keeping all of this in mind. And once again, we need to keep chain rule in mind. So y prime is going to be 1 over all of that, x cubed plus 1, times the derivative of that, which is going to be 3x squared. So the whole derivative is just 3x squared over x cubed plus 1. Now, a couple things to keep in mind as we're moving forward with this. Eventually, we're going to have to go the opposite direction of a derivative, which means I'm going to need to go from here to here using a process. That's not this chapter, but that is coming up eventually. So this is the derivative. All right, this one, y prime, becomes 1 over sine x times the derivative of sine x, which we now know is cosine x. We also know that cosine x over sine x is cotangent. All right. So this function becomes ln of x to the 1/2 power. And what we're going to do with that is I'm going to do the power rule first, which means the 1/2 comes down. So f prime of x is going to bring the 1/2 down, times ln of x to the negative 1/2 times the derivative of ln of x, which is 1 over x. So this whole thing becomes 1 over 2x ln of x to the 1/2. So I'm just going to put square root the ln of x. Not too crazy. A little, but not too much. All right, for this next one, we're going to have to use our second rule here because we're no longer base e. We are now base 10. So f prime of x is going to be 1 over that times the ln of 10 times the derivative of all of that. So the ln of 10 comes from the rule here. And the derivative of this, derivative of 2 is 0. Derivative of sine is cosine. So overall, we have the cosine of x over all of this. Okay. Next up, we're going to do something called logarithmic differentiation. What that means is I'm going to take the logarithm of both sides of this equation here. You can take the log of any base that you want. It's going to be way easier to just stick with base e. And I'm going to rewrite that as x squared plus 1 to the 1/2. And if you remember your basic logarithms, we can expand this into 3 separate logarithms. And remember, the exponents come down. Remember, when you're dividing, it's subtract. All right, now, when we take the derivative here, this is going to be 1 over y, but remember, y is a function of x, which means it's going to be 1 over y times y prime. Because 1 over and then the derivative of y is right there. And this becomes 3/4 times 1 over x plus 1/2 times 1 over x squared plus 1 times 2x, remember chain rule, minus 5 over 3x plus 2 times 3, because of the derivative of the inside just becomes a 3. We're going to clean this up a bit. And I'm going to multiply the y to the other side, y times 3 over 4x. And I'm going to note here that the 2's go away. I'm just left with plus x over x squared plus 1 minus 15 over 3x plus 2. So overall, I have all of this, x to the 3/4, square root of x squared. This is just y, plus 1 over 3x plus 2 to the 5th times all of this, 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2. And that monstrous beast is your derivative. Let's try to separate that out like that. That's a long one. You got to be really careful with that, especially with all the details that are involved. All right, we're going to do this again. Logarithmic differentiation. I'm going to take the natural log of y equals, and I'm going to bring that down, root x, ln of x, and be careful, I have to do product rule here. Now we've done the derivative of root x before. And I'm going to use that fact when I do the derivative here. So this is going to be y prime over y, just like we had over here. 1 over y times y prime. Now I'm going to do the derivative of the first part, which is here, 1 over 2 root x ln of x plus root x over x. And we're going to clean that up a little. I'm going to multiply the y to the other side. And we could actually simplify this even more. I'm going to leave it as it is just to not confuse things too badly. And y, remember, is x to the root x. And that is logarithmic differentiation. There are other ways to use logarithmic differentiation that makes a lot of the derivatives a whole lot easier. I hope that was helpful.